So now we're going to be thinking about this idea of surface area. So if you break that down, right, and you think about, well, what is a surface? We could think about that really is like our face, right? So if we have a three-dimensional figure and we want to find the surface area of it, oftentimes we'll think about surface area as the area of each of the faces, right? What's the area of this and the area of this and this and this and this and all of the different faces, right? And so sometimes people will think of it like, how much wrapping paper do you need to perfectly, without any extra, cover this cube or this die, right? That is the surface area. So if you think about wording of how to say what that is, it's the sum, the answer to the addition problem, of all of the area of the bases and the lateral faces. So if you think about whatever your shape is, if this is our cube, if this is our figure, right, we're going to find the area, the two-dimensional area of this face and this face and this face, right? Or you could think of it like base and top with all of the four sort of lateral faces around. So what can we use to help us find the area? Well, we can use these things called nets. So what you're going to do is you're going to practice this. You're going to label the dimensions down here on the given net, and then you're going to find the surface area of this solid. So we're taking a three-dimensional figure and we're turning it two-dimensional so that we can find the area of its surfaces. Okay, so in other words, we're going to say, okay, we know that the base right here, if we call this sort of red, right? This is also red, and this is the top, so it has to be the same. So we have two of those. Well, what are the dimensions there? We're given that the length here is 12. Oop, oop. So this also has to be 12. And the height is 4 centimeters. And I'm just reading that from right over here, seeing that that's really hard to write so small. So we have a length of 12 and a height of 4 for the base and therefore for its top, right? So then if we choose another color, we have these sort of sides over here. Sides we'll call green, and those sides kind of attach to the base and then come out, right? Well, we already have here that the height of this is 4, right? So that has to be true for this shape that is perfectly attaching to it, or for this face that is perfectly attaching to the base. So now we just want to know, well, how far does it sort of fold out? And we can see that the fold out, if this kind of went flat down, like we have over here, we'll see that we've taken this height. It looks like the height of 6 centimeters, but when it folds down, it becomes sort of the length. So this is 6 centimeters. So there's a height of 4 here, and then a width of 6. And the final face here, if we call it blue, right, we could say it's like the front and the back. So it's attaching to the base. You can see it kind of even turned purple here a little bit. And then it's going up and essentially connecting to the top there, and it attaches here. So we already know that the width is 12. It's perfectly attaching to that, so it has to be 12. And then we can say, well, how high up does it go? Well, it has to go 6 because it has to reach the same height as this over here in green. So this is 6 centimeters. So if we clean that up a little bit, you can see here we have our dimensions. Well, inside of each of those, you can see here that the next step is to simply find the area of each of those shapes, right? It's a composite figure, if you will now. So we're going to say 12 times 4 is 48, right? That will get us the area of this figure here. And we're going to do that for each of these figures inside to find the area of each of them, and then put them all together will get us the surface area for the entire rectangular prism. So we're essentially just going to add them all up. We have a 48 and we have two 48s. We have a 72. We actually have two 72s. And then we have our two 24s off to the side. We add them all up and we end up with a two-dimensional measurement of 288 centimeters squared.